Alrighty. Let's get started with this because I'm actually pumped for the work that we're planning on doing today. So, I know some people actually watched the stream last week. I came up with a good plan towards the end of all the good stuff that I wanted to do. And obviously I decided to do something completely different. Not a big deal. I think it's going to be more fun, more hands-on, and more importantly, I hope that by the end of the stream, we have, if not 1, 2 PRs open against the main cel-rust interpreter. So just for clarity's sake, again, let's do something quickly. So we're working off this repo here on GitHub. So you'll find the cel-rust organization, in which there is one repo, and that's this guy here. And yeah, so I guess I had like some music playing. I have no clue where this comes from. This is great. Anyways, maybe I can make this a whole lot less loud. So maybe we'll need that eventually. Okay, so this repo, right, that you can all clone and code along if you so want to. So I did that very obviously preemptively. So here is the code, and that's the current, that's an example that shows how you can wire in cell functions inside a program, like a cell expression. That's what we have here. We're like, okay, let's wire some functions in here. And so that we can extend the cell language, right, to do more things. What does that look like in practice? Well, actually, we could run this, but it doesn't matter too much. So currently, you can add functions and variables to this context here that you execute your expression against. One thing that you can currently not do, and that I'm still working on, let's say in yet another branch, is to add types. But cel actually comes with a bunch of types. I have the here, that is the Google implementation in Golang of the cel interpreter, and that comes with some additional features that are currently don't exist in the cel implementation of our interpreter right now. So actually, let's take a quick look at the diff that we have here. So if I reopen Rust Rover and I go to something along the lines of value, I guess, right? These are the types here that are currently supported. You see some of them are behind the feature. Technically, if you want to be compliant with the cel language specification, like duration and timestamp are not optional, but in any case, here they are. So yeah. What else is there to cover? Yeah, actually, let's take a different, let's diff the two things, right? So we have function types, which is actually open for debate. Then we have ints, unsigned ints, floats, string, bytes, boolean, and duration, timestamp, null, and we have map and lists here above, right? So if we compare that now with what we have in Go, it turns out that there's a different set of things. So there is the ones that we expect, the Boolean, the bytes, double, duration, and timestamp, so forth, string. But there are more, right? So there's some that we don't care about too much that I'll ignore for now, like the type parameter kind. Let's ignore that. The type kind itself, let's ignore that as well. But then we're left with the opaque type and any kind and the din kind. As you can read yourself, right, the din kind represents like something that is not known, that will only be known at runtime when we actually evaluate the expression. The any kind matches the Google protobuf stuff, so we ignore that as well. But the thing that we care about is the opaque type. So why would we care about an opaque value in our world, right? What's an opaque value? So an opaque value is a value that is opaque, so you cannot peek into it. You don't know any of its fields or nothing, but it is useful to call member functions on or methods on it if you want, right? So there is actually a type of opaque that exists in cel, which is, so this is the cel playground. We covered this last time, right? So let's fix this thing a little bit. So if I run this example, right, this returns false. So what this does is if account balance larger than transaction withdrawal, then like whatever this means, right? Like that's what we know. Let's say it's a way to decide whether we allow somebody to withdraw some money, right? So the types that are defined here in YAML, so we got a balance of 500, 700, we cannot withdraw that, right? So if I change this and make this 300 and rerun this program, this returns true. So how is this related to opaque? Well, it is not really. So there is this weird notation that we can run. Sorry, am I doing this wrong? It's actually like this, I guess. No, that was correct. Okay, so it's the optional notation, right? So this is probably what this tells us. No matching overload applied to optional din, right? So you can see those are din types because this comes from YAML, so we don't know what those are until we evaluate them. But in this case, that's not what interests us. So this optional din that we see here, right, translates to this right-hand side evaluation. Withdrawal is actually now an opaque type, and it's an opaque kind, as they call it in Go, that actually is an optional. So the way that it works is like this. So if we run this, now this works. So why does this work? Because, okay, so let's decompose this whole thing. So we go into transaction here, withdrawal, or value 0. So what this means is that now I can deal with the case where withdrawal, let's say I remove the A here and run this. Oh, that's interesting. This should return. Why is this not working? Okay, that's correct. Or, oh, sorry, my bad. That's, well, actually, okay, it's a bad example in this case. Let me do it the other way around. So we'll keep the withdrawal here. Just to stick to the example, the logic of this example, right? So if I rerun this, now we're back to square one. This says like there is no overload for this time left-hand side, right? In case we cannot go to the field balance on account, right? That's what this question mark here does. It's going to return like an optional type of type din because we don't know what balance could be, right? So the way to make that work is balance is effectively an opaque type. It doesn't show what composes it, but it gives us some methods that we can invoke on it. So in this case, I'm going to say, in case the balance is not there, I want to get a value 0. So if I run this, now it's going to be true because I got a balance of 500 and I'm trying to read the row 300. So this is fine. But let's say now I delete this field from the account, struct, I'm going to say, right? Or object, or whatever you want to call that thing. So let's rerun this, right? So now this returns false because it used 0. So why is this useful? Because if I would try to go back to what we initially started from and run this, this is going to fail telling us there is no key balance on this object account, right? So when you got let's say, really dynamic payload inside your cell context that you're operating upon, like this can be really annoying now, right? Because, oh, now I need to write something. If I don't have this way of doing it, like just with the optional syntax and the optional type that's implemented itself as an opaque type, I would need to write something like this: has account.balance question mark, then we do navigate to balance, otherwise return 0, right? So if I run this, and if I put balance back in here, balance, so without balance it returns false because it's going to be the ternary operator, use 0. 0 is less than withdrawal, so that's not working. I got 5,000, and now I run this. And that doesn't do what I expected. Why is this returning 5,000 as account? Then we return that. Oh yes, because I need to write all that in parentheses. And now we're back in business, right? So, okay. So you can see like this notation is very error prone, is very long and whatever, right? We can all agree that writing something like account dot question mark, I don't know whether it's there, balance dot or value 0 is probably more readable, right? All right, I got it. It works. I don't have a balance field, it returns false. All right, so this works again 2 ways. One, this optional thing is an opaque type of named optional, and what the standard library does in cell is that it wires the overloads on this optional type so that you can call those functions on it, right? So that's what we're looking at doing today is, one, introduce the opaque type, enable users to wire functions to that, and then we can look into providing the optional type and wire the functions like or value. There's actually a few ones I need to look up myself, but that's going to be for later, right? So that's what I'm looking at implementing today. It's going to come with one caveat though. All the work that I explained that needs to happen to support proper overloads in the cel-rust interpreter still needs to happen, because today, if we go back here and I go back to my functions here, when this happens, actually maybe it'll be fine. Maybe I'm talking, no, I'm not talking nonsense. So when you wire a function, right? So like this one here is empty. So you're like, okay, how does this work? So this uses quite, we'll have to implement it. So we'll look into that later. But so this adds a function is empty. That's the, like, pointing to this function here. So what is this function here? So this function uses a little bit of magic here to resolve what the function operates on. So in this case, a string, and returns a Boolean, right? There is a more generic way to implement a function. How is primitive implemented here? Yeah, not interesting. This one, I guess, right? So this is the full-blown function context, which lets you know like how the function is actually being invoked. Yeah, so this is possibly more useful depending on what we're trying to do. But that is what eventually gets called for the dist, right? So that we know what the type is on that thing. The problem is, so as you can see, this takes an option value, right? Because it could be foo, no arguments and no target, i.e. not a function, not something that, not a method, i.e. a function that takes a target as an argument, right? This returns an option value. And now we're back to where we were, right? Because that's what we're looking at doing here. So what we're looking at doing is actually so I'm on main right now, or master as it's called. So I'm gonna create a branch quickly. And I'm gonna call it opaque. That's gonna be a working branch. So what we're looking at doing here is adding an opaque type effectively, right? So that would be the first step, or possibly the first step. So if we do that though, we can already see there is an error somewhere because like bunch of stuff matches over that, and now we don't have like complete match statements for everything, right? So like here, for instance, and that's important because of some other code that doesn't yet exist. So that's interesting. So we may want to add our opaque here as well. Opaque, right? Problem solve. At least one problem solved. There's probably a bunch of other problems. Right. I added it after bool, I think. Value type colon opaque. Right, opaque. That's perfectly fine. We can actually have a quick look at how things look like. So I created this guy here. Right, cargo check. Have a quick look at, look at that. It actually works. That's all that needed to happen. That seems weird. There's at least one place where no things should blow up is when the interpreter eventually sees those things, and that would be inside object itself. Oh, maybe not. Maybe not indeed. Yeah, maybe we don't care about that because we have all the other things down there. So that's great. Maybe we'll break some tests. Maybe we can do that. See if we already broke something. Cargo test. Hey, look at that. We didn't break anything. That's great. All right. Get status. See what we did. Right. So we only get diff. All we did is adding the value type and the value opaque. Obviously, that's not useful, right? Because even though from cell you cannot peek inside the opaque value, there needs to be something in there, right? So if you retake the example that we had here, right? Even though this, so let's get rid of that. So if I run that, right? Even though the left-hand side now is an optional din, right? The fact that it contains, I know I got rid, the fact that it's actually empty, right? And doesn't contain a value, that needs to be known by that thing. So by this opaque value, right? That's the thing that I'm talking about. So how would we address that? So I have Actually, the reason I'm working on this, I should give the props to John Howard, because he sort of sniped me on that. And I was like, oh, I need to do all the work with the overloads and whatever. And then actually I realized I'm probably wrong, and this can be done already in the existing release cell interpreter. So the way I was thinking of going about this is by, so where do we have tests here? Yeah, here. This is really where all our stuff is, huh? Okay, well, what we can do is, let's do this here. Test. So what we want to have is tests opaque values, right? So now if I say I have a, what is it? Value opaque, right? Like opaque, right? I want to be able to put something in there. So what like, I want to have a struct in there, but that struct, so that struct would represent an opaque value. So there's a few things I think that we should probably do. Actually, one way maybe that I can show some of that is by, if we go back to our thing here and we go to optional go, right, that's literally what I was looking at. So if you look at the Go implementation, the way they do it is we do this optional type is a new opaque type of name optional type. So opaque types are named. That's the important thing that we care about, right? So if we go here, we can see that the run type name is how they call it, like is that thing. So it can have parameters, a type parameters. We don't need that, but and then the kind is opaque kind, right? That's what we do, right? So this is what this looks like. If we go here to the type implementation, we can see that it has the kind that we saw, the parameters we saw, the runtime name we saw, and then it has those things here that will just probably be not runtime. Yeah. Possibly useful. I don't know. I'll have to look into that. But the trait mask is important. So the trait mask is effectively the traits that this type implements. So here it's 0, right? Because we don't, as you saw, we were not initializing that anywhere, right? So the result of that is that it implements nothing. So in the cell interpreter is nothing you can do, right? Like example given, if I go back here, and let's say I would want to add up the balances together, right? So let's say no, I'm not. No good motions here, right? I would want to do this, right? So let me first do it properly, right? Like this, so that we're all on the same page here. Balance is 21, obviously. So if I run this, right, this gives me 42. But and the way that this works inside the cell interpreter again is it because integer implements the adder trait. So two integers can be added together, right? But if, oops, oh, there is some stuff going on here. But now if I optionally navigate to balance, right? So the return type is an opaque kind that is the optional type, and I run this is going to tell me that there is no such overload, right? You cannot add two optional then together, right? Like it doesn't know. You would again need navigate to or value, for instance, return a value so that either of the two is being returned and something happens, right? There is one thing that I would want to test quickly. I think that's a din, so it's going to work perfectly, though we saw that there are no parameter type to optional, so probably doesn't matter. But we can do or value 100, right? whoops, for value 100. So now if I run this, it's going to tell me 42. If I get rid of balance and it's not there as a field, it's going to give me 200. But now I probably can do this. Right? So this obviously, if it's not there, it's going to return me like the two strings 200 concatenated, because the plus sign on strings concatenates strings. But if I re-put the balance back in here, it's going to happily return me 42, right? Or if I redo it like this, it's going to be 200. Right. So because as we saw, it seems to make sense because of what I'm reading here, right? Or what we read here. Where was the optional type again? Here, I think, right? Yeah. So new opaque type, and new opaque type, we only use the name to create it, right? So if I go to the type declaration, this is where the params would be. So looks like optional has no type parameter. Awesome. Gonna make our life much easier, I think. Famous last words. We'll see how that goes. So back to our code, what we need is something to hold this value, right? So I'm thinking that possibly a struct opaque value that would have a type, how did they call it again? Run type name. Oh, that's a mouthful. So in Go, it's called run time. What is it? What did I say? Run type name. That would be of type string. And then we need our actual value, right? Now the problem is, what would value be? So I would think that it would be a boxed in any, but I don't think we can do that. I think it needs to be an arc, and as such, it needs to be plus send and sync. Why is this not happy? Yeah, import any, right? So that we can put anything in there, right? So any is kind of really cool in case you don't know, right? It lets us downcast something to that something in case that something has the proper type ID, right? So example, here you have a quick example of that, right? A string on a, what is a string here? Oh, here they do it, right? So here type of, right? So that's the trick that they use. And so the type ID is automatically implemented for T. That's great. Like for all the T's that will then be known as an any, we don't need to do much. Thank you, Rust. And then we can somewhere, we can downcast. Where is this? Yeah. Oh, no. Ooh, am I not? Okay, okay, that's weird. Okay, let me search that way then. No, okay, I cannot search this file. That is annoying. Very annoying. Like can I exit if I go here? Okay, now in normal mode, I go back here and now I can search. Yeah, but that's not the file that we're interested in, so we don't care. Right, now I can search downcast ref. There you go. That's a good example of what we're looking at doing, right? So being able to get a reference back to the thing of the type that we know it is. And the way we would know is by the name, right? Because we named that thing, let's say, opaque string, and as such, we expect that value to be, let's say, of type string in this case, right? Whatever it is that we want to inject in there. So by doing it that way, what we're doing is we're actually, for the first time, opening the type system up of the cel-rust interpreter, right? So until now, there was no way for you, as you can tell from here, right, to put anything else than known values in there, right? So you couldn't have arbitrary types injected in there. Now you will be able to. So that's going to make, I think, the life of a bunch of people easier, hopefully. Anyways, we'll see how that goes. All right, so where were we? Object, and we were all the way down here, right? So that's where we would do that. So yeah. Let's start by making all those things public. This may not be the nicest thing in the world, but let's see what gives, right? So now what we want is opaque to effective. Oh yeah, sorry. It's not that easy what we're doing. Probably we need to move this guy. We need to move this opaque value. Yes, we'll move it to objects.rs, but it's not helping me moving it. No, it wants to move the entire thing. Okay, sorry. I realize on the stream, like, you don't get to see the what is it called? The pop-ups or whatever. The windows that operate over this. All right, so we have map, we have key. These are all the specialist types that we have. Probably display for key, try into key, try into value, and here come our values. So I'm gonna paste this here. So that's gonna be a public struct, right? And probably let's implement the opaque value right away. We're gonna have a pub function new, I guess. Yeah, sounds good. How do we want to do this? Do we want to cheat a bit and make like s? Yeah, exactly. Into string and bang, and then we return self, and we're like, what is it? Runtime name cons runtime name dot into, and what is the other one? The value, right? Oh yeah, an arc. Yeah. So I was initially thinking like a box, as I said, right? The reason we need an arc is because if you go check here, right, like string is an arc, bytes is an arc. I must say I don't entirely think that was the best way to do all of that. But this is the way we have this right now, right? So like really it's all the way to the leaves of your ST and whatever, that every single thing gets reference counted atomically. So that's the interface that we have today, right? So that's the one we have to work with. So this is why it needs to be an arc. Then I said, maybe a bool would be great, but now that I think about it, I think it's kind of great that it's an arc, because that means that we don't need, like, when you get, we're decoupling the value itself here from the opaque value, right? So you don't need to keep a reference to the opaque value. You could have even like already a RC, an automatically reference counted thing, for which you then create an opaque value. So one that could outlive your context and so forth. So actually in this very case here, maybe that's a great thing in the end. So see, like, we'll see. We'll see soon enough. But so yeah, let's do that this way for now. I don't need this, do I? Can I not just do into string here and we get rid? Oh no, we do need it. Yeah, exactly, because that's not what we want. We want the call site to figure it out for us. So now we can create an opaque value, and we said that the opaque value needs to be inside our opaque value. Oh no, we didn't say that. Okay, so here what we need now is, does that need to be, no, oh, interesting. Okay, yeah, we can fix that. So we'll just derive debug. Not the others. Do I need the others as well? That'd be annoying. So, and clone, no, okay. Okay. All right, so now, still not good. Oh my. What? Arbitrary. I don't even know what that is. That's great. What's arbitrary? Oh. See, like this is always a surprise. I don't know what that is. I need to educate myself on this. Okay, well, let's do that. So let's go to browser, bing, crates.io, arbitrary, a trait for generating structured data from unstructured data. Oh, yeah, well, that is not gonna work. Ooh. That is problematic, possibly. Let's see. I actually don't know. I'm gonna try. Back to Rust Rover. Right, exactly, right? This doesn't work because it probably cannot do this on this guy down here. So that means I cannot derive this. I need to implement this myself, and it probably won't work. So let's say undo. Yeah, because there was a config, right? Okay. Config feature equals arbitrary, then implement. Yes, exactly. So what do we need to implement there? Whoa, that's a bunch of things. Yeah. Well, none of that is going to work for our type, I think. Yeah, that I did not expect. Arbitrary. You know what? I'm just going to cheat for now. What cheat? Like, make that problem for future me. And A, is that what you need? Okay, and then what we'll do in there is we'll return, what is that guy? E is error, and error is any error. Okay, that's great. Okay, it is not. There is not even none. a way for me to say that this is not something to ever succeed? Interesting. And then we're gonna do, well, I'm just gonna out error. Okay, I'm very sad about this, but yeah, let's say that's good enough for now. And then we probably have an error down here. Oh no, that's fine. Down here that says we need to ignore what's inside the value, right? So now if you go all the way back down here, this is not working because we need to say opaque value, new. We're going to call it, I don't know, string. Doesn't really matter. Now what we need is to have a let value. I'm gonna call it, I'm gonna make that the arc new, and I'm gonna call string from hello value dot clone. Right. Okay, well, that should work. Famous last words. Maybe we take a quick detour to our terminal window. And do a cargo check quickly. Yeah, and cargo test. Yeah. All right. I guess that works. Yeah. It's just this magic crate there that really disappoints me. Let's fix that guy here. And then where was that stuff? Okay, well, you know what? We'll cargo FMT. Oh, not cargo. That's not a thing. Cargo clippy. That works. Cargo check. That works. Cargo test. Why is it complaining? Oh, because I don't do nothing with the opaque value in my test. Okay, so then let's test for something quickly. Just to pretend that we've done stuff. So the reason I did it that way and kept the value, because now I should be able to do assert equal value. You know what? We'll deref that guy. Value to opaque dot. Yeah. Right. Wait, did I not make it public? Oh yeah, because opaque is yeah, that makes no sense. Let's get rid of the wrapping inside the thing, right? So it's the opaque, oops. Opaque value that we care about, like, right, the other one is just the enum thing. So data, no, value, oh yeah, value dot. Now what we want to do is downcast ref to string, exactly, and we want to unwrap it. So what am I doing wrong? Oh yeah, because I deref this guy, so I want to do as ref. Oh no, is this? If I deref, I get the string back like this, right? So let's run this test. Yeah, that would only work if we are in config feature arbitrary. All right, you go away. Back to my test down here, run this. And we are good. All right. So what did we do here? Now we added to the enum like the opaque value. The opaque value itself contains an opaque value struct. That's this guy here. And that guy in turn can be used. Yeah, it can. I'm sorry. I'm back to the arc thing. So we can use it to inject like an arbitrary value in there. Actually, let's do that maybe. What we want to do is create like I'm going to create a struct here that I'll call my struct. And in there, I'll do a field that's of type string, right? We don't really care per se. And now what I'm going to do is I'm going to get rid of this. And I'm going to change this in two ways. You'll see in a sec. So I'll do my struct field is like string from value, right? So this should now contain value. So this is now the runtime of this is say my struct. We created that. We do this whole thing. That's not gonna work because now I need to do that. My struct. That's still not gonna work because obviously we cannot. So we'll go to the field right away. That field, right? Okay, so let's run this. Bang, bang. There you go. And it passes. So again, what we now have in here is we're making sure that this arbitrary struct that like the Rust interpreter knew nothing about ever now can know about that thing, right? So we can inject inside the context. So for just to be really clear, it would be like let ctx equal context default, right? And then context dot add var. Okay, that one's a bit annoying. It's add variable from value that needs to be used, and I can say my thing. That's the binding of the thing, and now there I can say value opaque value. No. Opaque value, and I inject opaque in it, right? So this, again, should work. It makes no sense because I'm doing nothing useful. Oh, yeah, sorry, my bad. This needs to be mute. So let's rerun this test. Right, so now we can inject something inside the cell context that is our own, right? That does something. So the good news is we can even implement like interior mutability to this thing here, so that I can change this value, like let's say through a ref cell or whatever, right? And then I can update the value as I go because people, let's say, because how do you use my thing now, right? There's nothing you can do with it quite yet. That's the rest of the work that we need to do. It's making sure that you can invoke something on that. Right, like a method, so that you would have program compile, so that you could do my thing, because now you cannot go from there to the field, right? It's opaque, like this. We can try it if you guys unwrap. Let expression equals. Oh, it's a program? Okay, that's fine. Program, right? And then we can do program.execute, right? And I'm going to call unwrap on it because that should fail, right? There should be no field on my thing. So let's run this and bing, this fails, right? Like no such key field. We're trying to get field on my thing, but that doesn't exist. The thing that we could do though, is something like this. I'm gonna call it method, right? And invoke a method on my thing. So if we rerun this, it's gonna say the same thing, undeclared reference method, right? So we're calling method on like what is that even supposed to be? Like, I don't know. Let's try something quickly though. What happens if we do something stupid? That works. That's, yeah, we will have to do some fixing, it seems. Yeah, exactly, right? And if I make it a string, same thing, I guess. What? Let's run this. Yeah, something is, yeah, we'll have to check what's wrong here. But so let's ignore this stuff for now. So we'll delete those 4 lines here. Let's save this. Let's go back to our terminal. Clear. Cargo FMT, cargo tests. Cargo what? Cargo Clippy. Clippy's happy. All features. See if cargo is still happy. See how much we broke, right? Not much there, that's fine. Okay. Can do cargo test. All that seems fine too. All right, well, I guess that's a start. How about we commit this, git add -p. So, oh yeah, you know what? Let's not do that. What will, like, let's go back to our ID. There's 2 things I want to check on first. One is this arbitrary thing that still annoys me a little bit. So we implemented, where is it? Here. Like, this is not the proper error. So can we do something different? What we want to do is what? I'm going to be very honest. I don't know exactly what I'm doing. I need to look into this arbitrary library a little more. Yeah, but it slightly scares me. Like, I'm like, I don't really know what we're doing here. But so error can be any kind of error. So create. Yeah, so that doesn't work because our errors don't. Oh no, they do. Oh, is this? Yeah, God damn it. So yeah, expected error, but found that. Okay. So error. Error is, oh no, we're really stuck with those things effectively. Oh my God, that's bad. Oh, there is not enough underlying raw data to construct, but that's never really what we care about, right? Incorrect format. The raw data is not of the correct format to construct this type. Empty. Choose unstructured. Choose must be given a non-empty set of choices. No choices were provided to the unstructured choose call. There's no way for us to error out of there. That's awesome. So that's really great. Whomever wrote that. Yeah. Well, because that's never going to be the case. We'll never be able to implement this method as is. Like, that's too much magic if I get this right. Okay, well, then, you know what? We'll stick to what we did before because we don't really have a choice. So arbitrary, colon, error. Which ones should I choose? Like, we got a few viewers on. Anybody has an idea? Like, which it's gonna be all right? So, empty choose, incorrect format, not enough data. Yeah, I'm gonna go for not enough data. So it looks like I imported something up here, right? This guy here. Oh, but I had unstructured as well. Imported, where is that being used? Oh yeah, so I can just do that. I'm gonna do arbitrary colon, so it's explicit, and I'm gonna get rid of this entire thing up here. So if we go back to our terminal scene and we cargo test everything, cargo test without the feature, cargo clippy all features. Yeah, okay. So let's say we don't really have a choice here. And now back to this. So the other thing I wondered about, should we put additional constraints on what can be put inside an opaque? And here is what I'm thinking about. No, I think we're fine actually. Yeah, I think this could be good enough for now. Okay, so let's say we roll with this. So back to our terminal, and let's advertise the work that we've been doing. So git add -p. Yes, what? Why did we, where is this? In objects, line, oops, line 11. Here, why did we include time zone? What? Oh yeah, crap, I should have switched window here, sorry. Yeah, well, that is surprising. Oh, because I deleted code here. All right, let's do that. Let's get rid of that. Oh, let's do that. Get rid of that. Get rid of this guy here. Okay, that's a really weird change set. All right, whatever. Sorry. Let's redo this. Clippy all features. Cargo FMT. All. And let's add our changes. So yes, we added any, that makes sense. We created this new opaque value struct that right now is all like visible to the world. I hate this run type name thingy. I think I should just call name, but we'll see about that later. So that sounds good. So let's say yes to that. And yes, we added the opaque variant on the enum, that's nice, and on the type as well, and there as well to write that type out. Yes. Now we added the test that needs to have the ref and the opaque value from above. Yes, and we added a test for that, right? So git push I'm gonna push it to my own branch right now. And so let's go to GitHub, cel-rust, and that should tell us that nothing. That's great. I'm signed in. Yeah, I want to do a pull request. Sorry, I'm checking that. Not branch-v, remote-v. Sorry, quickly checking on the side. Yeah, that's mine. Oh, is it because of the move and things? It doesn't realize. Let's try new pull request. Compare from. Okay, then let's do this differently. I'll go back here. Code. Copy this. Okay, let me go back. You'll see what's going on in a sec. So git remote add. I'm gonna call it upstream. This git push upstream opaque, right? Okay, that is better and better. Is the opaque branch not there? What the heck is going on? Oh no, it's there. Okay, so anyways, go back to a browser, say we want to do a new PR. I don't know why GitHub is not telling me, hey, let's push a PR here. Doesn't find it, that's fine. New pull request compared to opaque. And it says there's nothing to compare because I never committed. I'm an idiot. So I just, right? That's what I did, right? Yes. Git commit -sm feat opaque. This adds you know what, I'm gonna do it like this. Feat opaque adds support for opaque values. Add opaque values. All right, this adds opaque variant. This adds n or a, I don't know, variant to the value enum. Adds the matching kind. An opaque value holds a struct with the name of the opaque values type along, let's do this a little better, along a arc din any, it's more than that, but that's what I to the actual Rust value. Right, let's do it that way. Quit git push Alex opaque. Whoops, Alex opaque. Bang. So now hopefully if we go back to, yes. All right, compare and blah, blah, blah. So I'll do this. I'm gonna create this as a draft pull request and I'm gonna add some information. There's a few tests. There's a few things that still need to happen here. Fix the interpreter to properly deal with these values, these opaque values. Example given, currently they are equal to anything. What else do we need to do? Add an example to, you know what, I'm gonna add this as a to-do list so that others see where we are. For example, to use these to add functions, like to I'm not sure how to call this best here. Should we say functions? I'm going to say add an example to use these, and which adds what are we adding? Which adds methods to these. Yeah, anyways, this came out of a chat with or John earlier this week. I got really nerd smart on that because it would let me add support for optional much faster than my initial plan. So the one downside to this faster approach though is that we can't overload methods as of now, really, without having the function used for a named method or function passing the target in, which is not really what the cell spec says, but what we have today anyways. Without as it would need to do the dynamic dispatch on the mouthful name. Run, crap, I forgot. How did we call this guy again? /runtime_ type name. Type name. Okay, let me reread the sentence. This came out of a chat with our John earlier this week, blah, blah, blah. Yeah, that's fine. The downside of this faster approach, though, is that we cannot overload methods as of now, really, without having the function used for a name method of without having the function know about all the target types, as it would need to do the dynamic dispatch on the run based off, probably that makes based off and let's open this draft pull request. So the reason I did this way is so that people know what's going on, right? What's coming and so forth. We'll see what people say. This should be pretty much good, actually. Like, there's a few things that right now I'm hesitant upon. Is like opaque value. Is it sync and send? Like, is string sync and send? Like, we can quickly check that. Rust string. Yes. That's it, right? Trade implementation. Sync and send. Okay, so we're good because the arc that we're composed of is, so is the name that we have. So opaque value is sync and send. Okay, so that's great. So actually everything should be fine. Famous last words. This arbitrary thing really annoys me. But I don't know how I was supposed to do that. So we'll see. Okay, well, so what should we do next? We have a few options here. I would start by making sure that, let me try something. So every time I don't know something, I use this guy here to do stuff. So what happens if we do this? Whoops. Account question mark balance equals and equals. So what happens in that case? That returns true. That's literally what I expected. So equals works, right? But so if I do this, that's going to return, I don't know what you're talking about because there is no such overload. And indeed, it tells me matching. Found no matching overload. What we expected. But so they should be comparable. So if I do now, so balance is there. If I change this to account dot question mark overdraft. Oh. Overdraft limit, and I run that. That is false. But if I made the overdraft limit 100 and I run it, that is true. If now the value isn't there and I run it, that is false. And if the value isn't there, that is back to true. Okay. So in case an optional, so it does peek into the implementation, right? So I guess what the implementation does is it's effectively an optional as an option of a cell value. If both are none, then they're equal. If they're one of them is none and not the other, they're not equal. And in case they're both not none, they delegate to, I don't know, maybe left-hand side dot equals right-hand side. Maybe actually if the left-hand side is non-nil or non-none, like is some value, it delegates to the left-hand side dot sum. Yeah, that's fine. But so that means that, so can I do that though? Run. So that says, I don't know how to deal with that. And what if they were actually that and I run the same thing again? Okay. So I think I know how this is being implemented. And the key part here, and that's something that we don't have right now in, well, I'll have to double check. I'll double check. So let's do one of two things. Go back to this here. Go check why my computer is getting really, really hot all of a sudden. Because last week, I don't think that happened while streaming. What could go wrong? Shit could catch fire. No, I think we're fine. Famous last words. Yeah, it's my Rust rover is actually the one that's annoying. Whatever. Okay. Okay, so I think the way this works is because in Go, they made what I found was an interesting decision. Where is that though? I need to refresh my memory for a sec. Is it inside deck slash val? Right? So val, which represents the interface that the value is, implements equal. Has to implement equal. So that means now that that would be our opaque value in our case, right? So opaque value will need to implement equal. Huh. Yeah, we need to do that. And obviously, you know what? Maybe that can be derived. Let's try quickly. See what happens if we say that we want this to implement partial equal, I guess, is all we need, right? Right, because that one doesn't have it. But if, oh, and that one cannot have it, right? I cannot do this, right? Can I? Yeah. That makes sense. So I cannot derive. So how do we do that? We could do it that way. I don't know how to best do that, to be honest. Anyways, let's try to first see how actually equals even works currently in the interpreter, because I haven't looked into this in a long while, because I knew that equal was the way. Hello, Kyo-ho? Hopefully I'm pronouncing this right. Yeah. Okay, so let's first see why we had our tests failing there, right? So let's do the test. So let's have a failing test, effectively. Tests, FN test, opaque equal, I'm gonna call it. And oh, let's try something. Let's try something. Let's try let opaque equals opaque value column new, we call it foo, and can I do this? Never tried that. That's fine. All right, great. And foo bar, and now we can do let program equals that. I have no idea what the idea is trying to do there, but so equals bar, and we do let mute ctx equals main ctx dot add variables from value foo is foo. Bar is bar. And what we want is we want that to return false, right? So that should be assert equal program dot execute passing in the context. Is it a ref? I think it is, right? Oh, I don't remember. What is it? What is it you need? Is it not program execute? Yeah, execute, right? Context equals, okay, value false. Why is this not fine? Oh yeah, because I need to have this be cell value con opaque. Value con opaque. Now, if you run this, that's going to fail because that's going to return true. Oh, that succeeds? What? Did we experience something else before? Oh, no. Look at that. Oh, no. Yeah. Wait. What? I'm confused. Sorry. My bad. Equals bar should be false, right? Foo is not equal to bar. Let's rerun this. What did I do before? Was I drunk? And if we say 1, what? Okay. I'm so happy this got recorded now because I don't know what I tested before. I'm pretty sure that. Okay, let me, I don't know. I'm very confused. Foo equals to bar should be false. And if I run this, it tells me it's false. Well, that's what we wanted. That's great. So there's nothing for us to do. Now the thing obviously becomes that equals foo should actually be true, I guess, right? And if we run this, this doesn't work. Okay, so this at least the equality. Do I need to fix like what I said in the PR? Edit. Gonna do this like this. Make delegate equals contract to what? To value? To opaque? I don't know. I'm gonna say handle equals contract in for opaque update. I don't know what I was saying up there. Like I was wrong. I had coffee though, single cup, but maybe that's not enough. All right, well, we made some progress on this. That's not too bad. That's not too bad. What do we, so right. And yeah, and adding the methods. The methods I think is going to show when we do add the methods, the support for methods, I think this is where it's going to show how the approach is actually not so great, right? Because there all of a sudden the limitations are going to become very, very obvious. But yeah. So you know what? I'm going to do two things. I'm going to make that one, and I'm going to make that one. Sorry. Prime. And maybe what we want to do here is have some kind of data in there. Well, we don't care, right? Like, it can be whatever. Right? Because what I want to be able to do is that returns true, and I want to make it so that this returns true too, right? Do we want to do like yet another one? Let's say this has, I don't know. Actually, you know what? Let's make them all 42s because that's going to be the best test, right? And this is going to be 43. So bar prime. Oh, wait. I'm an idiot. So that's our type name, right? So now that's what we want to call prime and bar prime. And now we need to add our guy prime here. Foo prime and bar prime and foo prime, right? So bar is equal, foo equals to bar is wrong. Foo equals to foo should be true. Foo equals to should be true. And then bar equals bar prime should be false. So which one did I say? Bar equals bar prime should be false. Is this correct? So let's redo this. Foo equals bar is false. That's for sure. Foo equals foo. Things should be equals to themselves. That should be true. Foo and foo prime are the same because they're the same type and they hold the same equal data. Bar equals bar prime is false because even though they're the same type, they hold different data. So I think that's what we want to make pass as a test, right? So, oh yeah, okay, I can do that if you want. I understand that. We want to have, that's a bit annoying, like, what is it? Oh, god damn it. Like Rust uses snake case and cell prefers camel case, so yeah. Rename prime. All right, so let's rerun this so that the linter is happy, everybody's happy, except the test is broken, which makes sense. Okay, so let's address that. So that's great. I like that. Rust Rover tells me exactly which line broke, right? Foo equals foo. So what we need to do is we need to go inside. So that's because I somewhat know the code here. There is something here that is the thing that takes care of equality for us. And equal calls not equal on the value resolve. Sorry, on value resolve, and then the right hand side, and so equals is equal and blah blah blah. So wait a sec, how does equal work? Where did we implement equal for value? Partial equal for value, yeah, I get that. And that's our partial thing. And so, yeah, here we always say everything is false, right? So this is where we need to have the magic happen. And honestly, yeah, how do we do that? So we want to have our opaque type here. That can an opaque type can only be equal to itself. That we know, right? So how do we, well, A and B. Okay, I can do that. Value opaque B. That's great. In which case, what is it that we want to do? That's going to be somewhat if a dot runtime not equal. Let's do it that way. Equals to b dot runtime type name. What? Then I'm gonna cheat a bit for now, but oh, whoops, we don't want to return here, then that is false, right? So I think if we rerun the test, that's still, I don't remember what we had in the test. Yeah, the last one should now fail, right? Because that's now going to check for all that we wanted. But the last one fails because we need to find a way to, in case they're both true, then what we want to do is, do we want to do this in a one-liner? Opinions? It's going to be too long anyways, right? So we'll need to Rust format it over multiple ones. So you know what? Okay, so what we need to do is a.value.equal, right? Is what we want to do. The thing is that this is not, doesn't have the proper bounds on it. And now I feel stupid because honestly, I don't know how to add this bound to it. Sorry, we want to go here, opaque value new, right? Because I cannot do this, right? Right. So can I downcast it to it? Darn, I'm not even sharing my ID. Okay, so just as a quick recap now, thanks for letting me know. Where were we? Here, right? We changed it so that the partial equal thing, wait a sec. That's the ORD, right? That's the equal one. Now takes care of this, right? So that we know what to do. Equal, but we need to be able to call equal on the value itself. So the solution that I think we should go for is have our own trait in between that would declare all the all we need. And the reason being that trait is actually the val trait that exists in the other branch I'm working on that introduces the entire proper type system stuff. So yeah, it's probably a lot of work, but it's probably gonna pay off afterwards. So I'm thinking that this may be the good way of doing this. I'm actually even wondering if we shouldn't call that. Well, we can't call it value because we already have value there. We could call it val as a trait and then do everything behind that trait, right? And make sure that that trait has all that we need. And then, you know what? I'm going to take a stab at this and do it that way. I lost where my opaque thing is. So opaque value, right? Effectively, instead of containing it, like, effectively what we want is this, right? Pub, pub trait val, right? That is any plus send plus sync, right? And then that has the equal method on it, right? Equal. Well, then val as well, right? And yeah, and we can actually provide a default implementation for that, right? Return false, right? So it's up for people to actually do the proper thing in that case, right? Like, sort of fine with that. And now what we have here is then val. And yeah, val. Now, obviously, we need, arg then val here as well. Right, so that's our constructor, blah, blah, blah. We end up here, like, why is this not working? What did I do here? Then that, oh, okay, yeah, that makes sense. Oops. So where were we? Where was the mistake? Then that false. Where were we? Here, 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 here. Inserting. Ref, right? And then something's complaining here. Oh, okay. Yeah, that's fine. Can I do that? Debug. Yeah, that I cannot do, obviously. Well, that's... I can also not do. The gift that keeps on giving. That's fine. It's an opaque value. I'm not supposed to see the value in it anyways. So sort of cheating. But let's say for now that's going to be good enough. bing, 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 and equals is false, right? So if we rerun this guy, why is this not working? Test opaque. Oh yeah, because, yeah, that cannot happen. Because that's wrong, but that should be fine though, is it not? Why is this not fine? Okay, what we can do is just right, because now we're done with my struct here, and what I need to do is import val for my struct. That I think. And now, yeah, we don't concern ourselves with the equal contract here. Let's move this here for brevity sake. So that works, but why is this not fine now? Dref. Oh no, not better, Annie. God damn it. Maybe we want to add it ourselves. Then val, that is any, right? Because that's the problem we have. Too many things open. Yeah. So that's annoying. Okay, I'm gonna cheat quickly. Where is our type here? Fn. What is it that we need? Value, self, then any. Oof. Actually, is this a good idea? No, it is a good idea, right? Because, right, if we go compare it, don't forget, right, what we're trying to achieve is to be close to our Rust implementation, right? Same thing again, right? So I think this is eventually gonna work. Where were we here? Right, yes, I know I need to implement value for this. We probably want to change the name though, because that's val value, blah, 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 whatever, right? That's not great, but why is this not happy? Import. And that is, oh, wait. I think I'm doing something wrong here. My bad. I'm implementing this at the totally wrong layer, am I not? If we check up here. Let me get rid of this. This is all annoying. Actually, opaque value is the one that needs to implement val. We don't need to go peek underneath, actually. That's the issue. Opaque value. Where did I... Wait, but no. Does that work? Yeah. Well, but no, because then I need to delegate to the thing underneath of it. And that may or may not work. Which could be fine, arguably. So let me explain. If we keep this any as we had it before, right? Sorry, any and sync and all that nonsense, right? What we can do is we can actually let's try this. We may not even need the trait to begin with. Because can I downcast to a... Let's get rid of all that. Debug for opaque. That sorted itself out. Or did it? Right. Get rid of that. Couldn't find trade val. That's fine. Implement open opaque value. Right, yeah, that's freaking annoying now. Percent plus sync. We're back to square one, right? And now the problem that we have is this, but actually the mistake I think I'm doing is I should just have this. A dot equals B, right? And it's going to complain that that's not there, but that actually on opaque value, we could implement it right away, I think. See, let's try this. Pub fn equals self and the other. And now what I think we can do is self dot value dot down cast ref equal yeah, that doesn't work, huh? Because equal is done, not incompatible. So I cannot do that, actually. I don't know how to best do this right now. Anyways, okay, I need a quick break in any case, so I'll be right back, and let's see if we come up with a good idea in a sec. Okay, I need to play with this a little more. I wonder now if the problem I have is actually not related to... If I do this, boxed in, and debug, is this fine? Right, it's not. So we need the arc there because of the other limitation that we have, right? Anyways, I don't know. Let's use the web. Okay. Rust box, then multiple traits. Oh. Okay, arc. What? No, that's not what we want. Oof, that's not what we want. Looks bad. Okay, but so wait a sec. What does that? Well, why does that work? Mm-hmm. Yeah, that's again not what we want. Yeah, we're not gonna watch a video on this. I don't have time for this. Okay, this is annoying. Box thin down multiple traits. Yeah, that's what we want, right? Yeah. So, ooh, AI is gonna save us. That works. But then why is it not fine? Copy tab Rust playground. Actually, let's get rid of that. I didn't check the code that I copy pasted. This is wrong. And this is wrong. And now this is wrong. And if we run this, right. Yeah. What are you saying? So yeah, so I guess we do need a freaking hello sophistic. So it looks like we do need we need to compose this trait ourselves, right? No, like the val thing, that path that I think I started upon is the one that we need. I don't think we'll cut not doing that. That's sad to some extent, but not too bad. I guess. So yeah, let's see if we can do that. Oh yeah, now the problem we had was downcasting then to the actual value afterwards, right? So that was annoying. That's annoying. Okay, I lost a bit of track of where we are, so let's try to rerun this test. And now this fails, yeah, we know about that. Oops. Because that doesn't exist. We knew that. Because we actually deleted it. So let's rerun this again. So that's not a thing. 5. Worst, yeah, I don't want to lose the test I rewrote. So yeah, so that's our method. We know that. And then the problem being what? Here, yeah, that's also wrong. That should be correct though. So if we do that and we go here and we cheat again, you know what? I'm just going to delete that for now. It doesn't really matter. Let's rerun stuff. Yes, that we can get rid of as well. And then we do fail at this one where we're not equal to ourselves, right? So that's the problem we have. And we need to solve it. We need to solve it. I actually need to solve more problems when I think about it, right? Because as you saw over, where was it? There's actually these two that we need to solve. So those are not too bad, equal and not equal, right? Because not equal has not equal. Oh, crap. Yeah, it's okay. It's a blanket implementation. It's the not equal one. So that's good. We could, should we test for that one as well? No, I mean, we know it's the other one, right? So we don't need to concern ourselves with that. Okay, well, and then that's where we are. We need to find a way to let R down here. When we create this new opaque value, we need to find a way to delegate to this value here to know what the equal contract is, right? And we cannot add this additional bound on it. So that's annoying. One way of doing it is asking for the actual function pointer ourselves, right? But that's meh as a thing. An elegant way would be nice, but none comes to mind to me at the very least right now. Because, yeah, oh man, that's horrible. Like, come on, there must be a way. I must be missing something. Hopefully something very, very straightforward. Something. It's two annoying things now, right? So we have this guy here that is still very annoying. And then we have this guy here that we want to sort of add an additional bound on, but apparently we cannot because it makes it a non. Let's retry this here. Okay, pub trait val any plus no equal. That's what we said, right? Yeah, we really want equal, I think, on that one. So if we do it that way, we now compose those two things. So here, technically, we can change this for val plus send and sync. What? It's not DIN compatible? Oh. Yeah. Equals contract, still very important though. We want that. We do want that. Wait a sec. So like this. Okay, we're gonna add. No, I'm not gonna add the send and the sync here. I don't want that. But I can do pub val. No, sorry. Function equal. Any val? Probably val. And we return that, and then fn value returned in any. Then if we have those, are we good then? Big value, yeah, implement the members. Oops. It's this one that I care most about, right? False. So now we want our opaque value that returns that. Right. So what did I implement value for? Like, yeah, this guy. And so if we go to the equals, where was our equal contract? In here, I guess, right? Yeah, okay. So now we have the value opaque A on the left hand side. We get the value opaque B on the right hand side. And now can we do A dot equals B? Sorry, what is that? What signature did I put there? Then val. Okay. Oh, then val. Why did I do that? Let's do it not that way. Let's. Oh, yeah. I know why I did that. So if we try to rerun our test now. Oh, yeah, well, that I know. That's fine. For now, obviously. Because now, where are we? Where did it fail? Yeah, what line? All right, this one here. Because the equal to foo doesn't work. Because we always return false. But anyways, that's wrong, right? That's the code that we had before where we were supposed to do the... Where were we? Actually, what did I implement? Keep on being lost, sorry. An opaque value? Okay. So what we need to do is self dot dot equals other dot yeah. No, it's fine. Its value equals, oh darn, we're back to square one, right? Like value is not comparable. So again, that doesn't help me. Great, party time. And then if I replace this with val, so that's a val now. Yeah, oh man, you are annoying me like really, really strongly. I think we did that, right? We implemented it manually. Implement. Oh, yeah, but no, if I make it here debug as well, then yeah, you know what I did before, right? So implement debug for opaque value, and that formats, and we only write our name. That's it, right? All right, up, and that's, sorry, how does that work? No, not like that. That becomes opaque value of some kind. Well, maybe, yeah, exactly. We can put the name in there, right? So we don't know what the value is, but I know we know the runtime type of that thing when stuff explodes, right? So we cannot derive it, but we implemented it. So that's good. So what else is still broken in this code? Oh yeah, other. What was I doing? I feel I keep on losing myself here. Oh yeah, because val is not to be here, it's supposed to be here. We don't want that anymore. And let's rerun this. Let's match types. Yeah, because that needs to be a val again. That's fixed. And then here, what we need to do is implement val for my struct. That's the one. And implement members. Wait a sec, do I already have a val one actually? In here? Oh, look at that. I did some of that already. That's funny. I had totally forgotten I had done that. And did we implement that for, look at that, for a bunch of things actually. I had a val type here. I had forgotten. And it looks, when you look, it looks like really close to what we're talking about here. The thing we miss on it is the equal method. So maybe I should use that instead. You know what? I'm gonna try this. Fn equals self other self, which returns always false by default. Actually, that's gonna be way nicer now, I realize, because if we can make that one work, so that one's a bit annoying because it has the, oh yeah, crap, all the type and the lifetimes and stuff. Actually, we're good because we probably have an opaque type here, don't we? And if we don't, we'll create it. Yeah. Let's create it. Okay, kind. Do we have a kind opaque? Yeah, we do. Okay, great. Things are looking better. I totally had forgotten I'd done that already. Okay, let's delete all this stuff here. Let's delete the other equal one that's somewhere here. Let's get rid of this. We don't need to see all that stuff. All right, we delete that trait because we actually have that trait already. Yeah, val, that one? Yeah. Create common value. I guess that must be that, right? So that solves that. That doesn't solve. You know what? I'm going to do something very horrible. I'm just going to do implement, right? So now when we run our test, like everything's going to blow up, but that's fine. We don't care about that. So what's the problem here? Val is not DIN compatible. How is it not DIN compatible? Because of the default impl? Oh no, because of that. DIN val, I guess. So now it's DIN compatible, right? Yeah, there we go. Okay, so that's fine. And okay, let's go back down here. And can we run this test now? And hopefully it fails. My struct doesn't. Yeah, okay, that makes sense, but that's annoying. No, that's fine too. Okay. What shall we do to fix this quickly here? We certainly can do that, I think, this one here. So let's do that. Implement val for my struct. Right. I don't think we need none of those. So yeah, I think we can leave them as to do. That's very evil, but I think it works. And so now we're down here. Oh no, that's where we need the into inner, I guess. Into inner. Yeah. And that moves it out. Cannot move. Cannot. Oh, opaque value. Then okay, I get that. Maybe we don't want into inner. Maybe we just want inner and not consume. Let's. Oh, that's implemented for all the types. Oh my god. Yeah, I did that. Right, that would need to be boxed, right, to make it all work. Like that would need to be like this, effectively. Self, right? Obviously that's going to complain because that's not what the trait describes. But so that's what we would need to do here, right? Box self. And now we consume ourselves. The problem with that, though, being that that also means that, like, we need to consume, and we don't want to do that there. So the way to fix this is what? What caused that? Did I find usages? Did I write tests for that anywhere? Test into inner. There you go. Yeah, because that boxes it and we're fine because value is that, right? But what if value is it in itself, then it cannot, right? So that's the problem. So this interface is maybe not the best suited in any case. Maybe what we do is we add another one that doesn't consume. Right, so that would be fn inner ampersand self that returns a din. No, but what's the use? I don't need that, do I? Oh, it's to do the downcasting back to the value if we want to. But do we need to get a boxed... Sorry, do we need to get the value inside an opaque back in any case? Actually, I don't... Maybe that's stupid. Oh, we do, right? Because we want to be able to do something with it when we get the box inside the function, right? So when let's say somebody calls something on that, right? I need to be able to get to the thing, which is the reason I wrote this guy here, right? But opaque, right? You would need to be able to get to my structure to do something with it, you know, like, I don't know, increment this field or return this field or whatever. So we need to be able to get to that. So one way we could do that is by implementing deref for val. Would that be evil? Maybe that's evil. Maybe that's evil. And if we implement it for this, only for this type here. Oh, target needs to be sized. Did I see that right? Or was it question mark sized? We'll see we'll see in a sec, I guess. Then what is it that we want on that? Did any, right? Right, and so what's the problem here? No, that cannot be. Oh yeah, it expects the din inner? Okay, yeah. So that? And, because, right, that's the din, it's a val and it returns as a thing. So I don't know if I feel good about what I'm doing right now. Because now if we deref, oh no, that's the arc. Yeah, that was maybe a bad idea. Because that derefs the arc, right? Which returns the ampersand. So now we need to deref yet again. No? Am I getting this wrong? Yes, I'm getting this wrong. Where are we? I'm lost. Deref gives us that, and that deref oh, whoops. Sorry, my bad. Yeah, I shouldn't use deref. Like, we already have this as an arc here, right? So what is value here, right? That's the arc. The value itself is the arc. And now this value, wait, sorry. Am I an idiot? Well, in general, yes, but can I do that? Oh yeah, I cannot. That would have been fun. Okay, let's not do that. That's moronic what I'm doing. So what we'll do is we'll just, did we implement anything on? Yes, here, right? We did. So let's do this instead. Like, let's add a pub fn. What do we want to call it? I'm gonna call it inner and say that inner will return the din any space. What the fuck are you doing? Right? And that's going to do that. And now, so how did I call this inner? I'm not sure it's a good idea again, but hey, we're a bunch of bad ideas. They cancel each other out, don't they? So we certainly don't want deref because that was a stupid idea. So why is this in? No, it needs to be inner. Deref inner. No, in on what? Me cannot read. Common val. But did I not declare that on val? What did I declare that? Where is val? Val, opaque, val, inner. Oh no, I didn't declare it on val. My bad. Wait. No, that's correct. It's that. I'm just calling on the wrong thing. Opaque. Inner, downcast, blah, blah, blah. That's what we wanted. Sorry, my bad. Maybe I'm tired. I don't know. So the val is not set. Yeah, that we know that none of that satisfies what we need, right? But so the good news is I think if we temporarily delete this code, so those, 19 lines, and we run this, knock on wood, that should succeed though. Oh, sorry. What did I am... We had another test, didn't we? Wait a sec. What am I doing? This test here. Yeah, this test. Sorry, my bad. That's the test we want to run. Right? Okay, but that fails. What fails? Yeah, I know that, but what line? Okay, it can only be that one, right? So, okay. So let's undo that delete. And let's say that we know this doesn't compile. So let's cheat. And let's get rid of all that. So now that compiles. That's great. So, and what didn't run? Field should be equal to field. Let's rerun this. Test opaque. Test opaque unwrap. Oh, was none because it fails. Am I returning the wrong thing now? So opaque calls inner. Inner is our value and it returns it as a din any. And what did we put in there? What did we put in there? Opaque, blah, 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 new, clone. New needs to take a val. That's the val. That's all the stuff that we don't care, so it can all blow up. That's fine. But actually, so maybe what I should do is, oh no. Well, can I? I guess I can, right? I can write this, some field, and then instead of here, I do map my struct, and I return the field, right? So I think that's fine. No, not fine? Because what, you want that? No? What is wrong? Cannot move the value out of there? Okay, that makes sense. So we'll do that. And that is what now the problem? And that return, why is this? Oh, because I can just do that. And now this would, I think, fail nicer. It's going to tell me like that we wanted some value, but we got none. Yeah, that's nicer. Okay, at least we got a good error message now. So it's nothing that really annoys me. And that's the unused variables somewhere. And I don't know where they are. Like Rust Rover has this tendency to just wanting to pull a bunch of random imports in that I don't know where it gets them from, right? Where's this coming from? I don't know. Decided we need mul. Great. Yeah, we can do that. That's fine. Unused A, unused B. Yeah, we know about that as well. Oh, did we fix that though? Can we call now? A dot E. Oh no, because I didn't do the. I didn't add those types. Oops, those types in quite yet. Those methods back in yet. Okay, so we're back here. So the thing that confuses me is why does it think that it cannot cast it down to struct now? Must be something really stupid. Because that should be fine, right? Like I probably messed something up. All right, so deref the field, that's literally that. Then we do inner. Inner goes to value. Can I actually do that right away? Or do I need to do it? If I go value dot, I cannot read anything. Import what? I don't know what's going on. Run this. No. That's wrong again. Downref doesn't exist on arc din val. Okay. Okay, can I do opaque? I'm a bit lost in the types here. Value dot. Oh, wait a sec. So wait a sec. What is val? Val is this type. Wait a sec. What am I doing? Why do we need that? God damn it. I should reduce the scope of what I'm doing. Trying to do too many things at once. That never works out well. New needs a val, and it's this val. That's fine. I'm fine with that. Oh yeah, this is why I said I need to add the opaque type in as well, and I didn't do that. That's fine for now. What else? So opaque value takes the val in. But so why was I hoping that it's, oh, because it's on opaque value that I said I added the inner type? Yes. But so that should be fine. Value goes to value, right? So it's val, and val is any. Oh, val is not any. Oh man, looks like that's the wiring that I'm not doing. Can I do that? That it's any? Yeah, that's fine. That's stupid. That's me. Is this fine? Oh, it exists, but the traits are not satisfied because my struct doesn't implement any. Is that what I was saying? All right, yeah, okay, that makes sense. It is implemented. I'm confused what your problem is, my friend. Let's have a quick look here, see if anything here came up. Oh, there was no way to have things like JSON. Yeah. Okay, so that's the person that nerd sniped me on this whole thing, right? So like JSON extends to work on a trait that just make one primary function to turn the opaque into another value, not an opaque, but other push, but the as any is annoying though. Which as any? In my code? In the code that we wrote this morning? Do we have that? I don't know. As any? No, we don't have that. He's probably talking about his zone approach. Cool. Let's have a look. It would be great to be able to compare because I don't know where the changes are. I don't know what. Oh, let's look at the commit logs. Work in progress more. Okay, let's see how they've decided to go about this. So inside runtime, why inside runtime? That is indeed a very different approach. Okay. I probably need to read through that code very, very carefully. What? Oh, okay. Yeah. Self arc, whatever. Okay. Yeah, that is a very different approach than the one that we took. And the as any is this what? It's on. I'm confused. What's that being? Oh, it's a trait. Okay. Okay. Well, at this stage, I think it might be wise to take a break from this, though. Because we have the basic there, right? So with our thing there, like it, quote unquote, like with the previous commit that we had, right? It works, right? It's just because we're trying to solve the equal contract already. But if all you need is a method dispatch, like I think that works perfectly fine in what we have right now, right? Maybe that's what I should focus on instead than fixing the equal contract, right? We could say right now that opaques are just never equal to anything, right? They're equal. Sorry, they're opaques, and we don't care, right? And then all I think we need to do is do the wiring so that the opaque can be used as a target for a function. But I think that could well be fine already, right? So maybe we want to try that and see if that approach works. Maybe I can still do this in the next few minutes. So you know what? What I'm going to do is I'm going to go to my terminal, because I think this, what we were looking at right there, is actually the solution to the problem we have. And we already had that one, right? So git checkout -b. Wow. Checkout -b opaque equal. I'm going to call it, right? Git commit some work in progress. So that's the way that I clean all my crap up, right? So I do this, and then I do git checkout minus. We're back to the other branch. We're gone with all that stuff. Now, technically here, cargo test, right? Everything works. We can rerun our own test from before, right? Run that, and that should work, right? So party time. Now, the thing is, what we want to do is add a function, right? This kind of thing that we see here, to work on targeting our opaque, right? So we could extend, I think, this here and do a test, fn test opaque fn, right? And so what we need to do is sort of the same as what we had here, right? I'm going to recoup like all this nonsense. You know what? Maybe I can do a mod opaque in which let's get rid of this pane here, too much noise. So those 19 lines, we're going to paste them in here. We're going to extract this struct in the opaque thing. Yes, this is probably all that stuff needs to be imported. That too. Import, blah, blah, blah. And looks like we need to import dref as well. We can do that. All right. Let's probably, you know what, let's run all the tests in this module, see what where are they? Here they are. Run all that. Yeah, so all succeeds. That's great. We don't need this anymore because we cleaned that guy up. Let's rerun all the tests. Looks like we still have like the dref here that we don't need. Let's rerun all the tests again. And now we're clean, right? So, okay. So now what we need is sort of the exact same as what we're doing here, only what we want to do is use it inside a program and actually be able to wire a function to that my struct there, right? So let me try to do some of that. Okay, we have the opaque. We don't care about that. What we care is let mute context equals context billing default. Oh, that doesn't have a default? I thought I had a default. What is going on? What again? Did I import the wrong thing? Yeah, that's wrong. That's not what we want. What we want is the one from import from the crate, and oops, and we add the default ctx.add variable from value opaque. So we're gonna call it like mine, and we'll wire opaque in there. We'll clone it. So, oh no, oh yeah, sorry. whoops, value opaque. So now we have this thing in there. Now what we need to do is ctx.add function though. And now what we want to do is my function, and my function should target opaque. So now I every time need a refresh on myself on how to size, say. So where is that being used? Somewhere, something must use it. No, that's function context. That's too smart. I want something like really simple, like this here, I think is what I want. I think that's the method signature that I want. This. Right, so let's try that. Maybe I'm wrong, but maybe I'm not. Hello? My function, this takes not, can we target the type right away there? Opaque, does that work? No, like, I never know what is what. So that's, yeah, well, sorry, that I know. Yeah, that's wrong. Okay, so that doesn't work. That's fine. If let's I thought there was a way. I'm pretty sure like I've done that in the past, like this find usage. Let's see what we have. Right, this here. There you go. Arc string, that's the internal, so it's this. I think what we need here is not this, but it's this opaque value, right? And I think if we do, whoops, I think if we do that, why is this complaining? Yeah, because that's wrong, exactly. So let's go back. Contains this result. It's this guy here that we need to find, and that's an execution error. Okay, so execution error. I'm taking like a big shortcut here. Execution error, and I'm gonna ah man, I just want a stupid error here to be like to get something, you know, like unexpected type. Yeah, they all want and missing fields. Yeah, that's fine, I don't care. My function, we're gonna make that more cel-y like. Whoa. And that becomes my function, right? And I think, no, not good. Oh yeah, because we probably need to fix it for opaque value, like the this trick there. Okay, so this here, if we go here and blah blah blah. Oh wait, I'm wrong, it seems. This pub t, yeah, that's great. Why is this not fine? Why is it fine with function, the name into function? And then, right, that's probably where all this stuff happens, right? So implement, oh, no. Why is this not fine? Where is the code that wires that stuff together? Okay, I'm gonna do it yet again a little different just for the sake of time, because we want this magic in, but we don't need this magic in. Because what we need is this. Right? That's the... Wait a sec. Is that the ultimate one? Maybe not. Maybe not. Actually, let me cheat quickly because I implemented one very recently. GitHub quadrant wasm shim. So I can show you what I'm looking at. Nothing secret here, but so I wrote something somewhere, probably in data, probably in cell. Nope, probably in cell here. And then if we search for response body, right, that guy. So that you must call into a function somewhere. This guy here, right? Okay, so that's what we want. Just gonna do that. Copy. All right. We go back to our browser. Let's implement that method signature. It's gonna be sort of easier. Oh, did I not copy this? Paste. Yeah, I did. Okay, so that's wrong. That's correct. That's wrong. Now this becomes my FN. We need to import this guy. Import. Bing, bing. So that's happy now. Now, technically, if we write a little program again, let prog equals program compile, and now what we do is, what is it? Mine.myfn, and we call that thing, right? So unwrap, that should be valid parsing. Let value execute the program, and we're gonna call unwrap on this. And this should, if I have done things slightly correctly, fail, but with what we expect. Oh, invalid argument count, expected 1, actual 0. That's true. Okay, so then maybe that is what we need. Let's rerun this again. And this should fail exactly with the gut one, right? So, oh, okay, then I did say something wrong, and we should be able to get, where is it? Here. Here we should then get the target from ftx dot this. If let sum value opaque equal this, is this the thing? Then no. Well, what's wrong? This option value is that. So what am I doing wrong here? Anyone? No? I also don't know what I'm doing wrong. Oh, I'm moving the guy out. Can't do that. That's fine. Then I'll keep on cheating, right? So what I'm doing is I'm just slowly making progress. Got FTX. Got opaque. Return. Right, so let's rerun this. And what are we getting here? Got opaque. So we got the opaque. And now what we can do is what can we do? We can, what can we do? We can return another value, right? So what we can do instead is say, and we'll use our thing here, right? So this is the wrong error. I'll fix it, but let's do the opaque, right? So opaque dot. Oh yeah, so if opaque dot runtime equals, that is really, really shitty, to be honest. Like I'm really, really disappointed that we have to do this, right? My struct so got, what is it? Opaque. You know what? I'm just gonna do this like this. Got opaque dot runtime dot clone, and what we expected was my struct. But if we got the proper thing, so I'm gonna say that expected type, expected value opaque. No, oh God, sorry. Value opaque, but we did get something else, and that's ftx this. ftx dot this dot kind of that. Oops, sorry. Like this? No, not that. What is it? Okay, that probably has debug, right? So got, I'm gonna just put a string there. It's gonna be easier. Format ftx dot this. Right, so we're good again. And no, that's not good. Oh yeah, here we want to, oh, you know what we'll do? We'll do what? We'll do that. And just return on the entire thing. That makes cleaner code, I find. So that's going to be an else again. See, like this is, and that's the problem I was mentioning at the beginning, because now if you want to, right, you wouldn't need to have a branch for all of your types here, right? So, okay. And that becomes now, how did we get to it again? Like, we can just do that. What the heck is, like, I think, yeah, that's funny. I cannot paste. Oh, whoops, that's wrong anyways. Okay, so you know what? I'm just going to get rid of that and implement the whole thing manually. It's going to be faster. Value downcast ref to my struct, right? So unwrap, because I just decide and I'm crazy and I clone this guy and into, right? All right, so now if we run this opaque test function, that passes. Why does it pass? Because it's not an error. So what I'm gonna do is I'm gonna get rid of that again. No, oops, sorry. What did I do? What did I do? Nothing wrong, that's fine. Unwrap. So what we do here is we're gonna do, oops, sorry, this, and we're gonna do assert equal, okay, value string arc new, what is it? I forget what value dot into, And I think that is about correct. Sorry, too many things, right? So that assert equal, why is he not happy? What did I do wrong? Man, that's a mouthful. Okay, so that, what? It wants a value? Oh, because I unwrap. Let's not unwrap, right? Let's just, so that makes for a cleaner test, I think, right? So let's run this, see what we gain. Right, there you go. So we now have a way to write those things in, right? So we just did the work, and that's a nice way to wrap this episode up, don't you think? Like, we didn't solve the equal problem, so we still have a problem, right? So they're sort of very shitty class citizens or something, are opaques. But now, right, what I'm doing here is I'm, okay, let's take this slowly. Let's start from the beginning, right? So we create a context in which we add a variable that's opaque, mine. I wire a function with mine here that now I can call mine.myFunction will peek inside the struct that my struct is. So where is that stuff? Well, let's have a look. Here we create the whole thing and we write value into this, right? That's the magic value. So value into this field, right? So let's change it to value, right? If we rerun this right now, that's gonna fail because we got value and not value out of the cell expression, right? So there you go. So now that does it, right? So quote unquote mission accomplished, right? That's we provided support for equals. For opaque types and binding functions to them, right? So the thing that's really ugly, but that's now because of the way the interpreter works currently, it's not proper overloads, right? You need to write all this stuff there, right? Anyways, let's cargo test all the things. This works. So we didn't break anything. Let's format our code so that things look beautiful. Git status. So we only modified object. Git commit.asm feature. What is it? Opaque wire function, right? Example. Wire function. Damn, today is not a day. Example, right? All right. Git push Alex opaque. So now let's go back to our browser window here. We can go back here. So the bang. And just say that add an example, blah blah blah. So I'm like telling the guy that I think stuff is there, right? See the example I just added and let me know what you miss. What you would still be missing there. As I mentioned, dynamic dispatch of a method name to multiple types, including so whether opaque or other requires the function to know about them all. Also, still pending is solving opaque, what is it? How do we call it like again? Opaque value, I think, is how we called our struct. Opaque value equality. They are currently all not equal. Well, there we go. The branched up, all the work's there. Anybody can go and have a look. The equal, I think, is a problem. Like the JSON stuff and all that, like, yeah, somebody has to write logic for that stuff, right? If you want some, I don't think like that should even be supported. Sorry, you mentioned that somewhere, like the JSON stuff, right? So I'm like, yeah, sure, great, but it's an opaque. I don't even know what the contract there is. We can have a quick look actually, right? So if we go to cel.dev and then scroll down again, go to the language definition, and I'm like, there is some JSON stuff somewhere. JSON data conversion, right? So that's what you get. So I think, probably should be delegated to the thing underneath of it. Again, it's a bit like equal again, right? Like the opaque value itself shouldn't concern itself with that, right? It's just, I'm gonna type foobar, like the runtime thing, like in this case doesn't even matter, and then just call into the underlying, right? To do those things. So it sounds a bit like a use case equal to the equality contract that may need to be passed on, but I don't know how to best address this, to be honest, right this moment. But anyways, good stuff. We made some progress. We got code compiling, we got test passing, and we get a way to now be able to do stuff, right? What I like about what we did as well, just to be really clear, is because we have the value here, right? Like I initialized this to this. So take a look at that, right? I can do this. Actually, let's even do this here. Value dot borrow mute field equals my struct. Why is this not working? What? Oh, maybe I cannot. Yeah, maybe. Yeah, because it's. I would need to have something else in there to be able to do internal mutability, right? So what could we do? We could cheat somewhat. If I change this example, for instance, to be atomic, what do you like? I30 new, and then I give it the value 42, right? So that's, oops, I need to fix this inside my struct. Oh yeah, fuck. Okay, I don't want to do this because I need to change all my things. But the point being that I can have a mutable reference in there. I still have value, right? So value here is like the arc is cloned into. So I can keep it. I can do changes to that and they will all be reflected down here. Right, when I evaluate the whole thing. So this is great, I think. Whether it's a good idea, that's a different to actually do that stuff, like do changes like this, like these underneath, whether that's a good idea or not. I'm not gonna argue with that point, but let's say it's feasible, right? Might not want to do it, but if you feel like doing it, you can do it. Anyways, all right, I guess that's it again but at least we went all the way from problem statement, opening the PR and so forth, right? So we need to look into the equal contract now, but what we've done here, right, with adding this function here is what we would need to do on the optional type. So if we go to that would be sort of the next step, right? If we go here and we search for optional, right, that guy here. So I don't even know the stuff. Oh, none apparently it has. It has get value. Oh, you know where I'm supposed to find this? In the standard library, I think. If I go here and here I search for optional. No, not here. Here. Optional. No? Undo. Or value, it's called, right? Or value. Ooh, that's not part of the stdlib. Is this not where we do all the... Yeah. Oh, you know what? It's probably Go code, like behind something somewhere. Type conversion matches, get time of the day. Where is the optional stuff? Okay, not here apparently. Optional. Bing, bing, bing. Get value. Convert to native. Equal. String. Yeah, that's great. Optional off. Optional none. Oh, yeah. Ha. Okay. Well, I don't know. I need to read into this, I guess. If you go back to a browser and we go cell optional or value. How did I know that or value even existed? You know, like, yeah. Explanation, optional value, right? No, I know all that. I want to know. Oh, let's ask. Cell optional. What methods exist? Yeah, that's a really weird question to ask, but anyways. Has, yeah, we know that. We want that one. Yeah, that doesn't explain it. Okay, so whatever the do we have optional here? Optional type helper. Optional. Yeah, but that's go code, is it not? What I care about is the... Okay, we'll never know. Oh no, maybe that's that. Oh, so there is value. This has value. Has value, or off one, or off two. Yeah, okay, I get that. Or value. Okay, so there you go. This or value has value of non-zero value. I didn't know that was a thing either. None and off, right? So these are all the methods. Well, actually, those are not methods. Those are functions. And yeah. And no. And which one then? And value, right? So those are methods. All right. Good. But we still want to have the support for that stuff here, right? Which is run, why is this balance? We don't want balance, go away. Run the overdraft limit, go away. Run. No, what was the thing that we had? Oh, they have to be there. Is that what we said? Is this all broken again? Let's try this. Question mark and question mark, right? And then we run this, and that says, I don't know how to do any of that. Oh no, my bad. Sorry. Ugh. Here, it has to be this. Run. Yeah, false. Exactly. Make that 5, run true. Yeah, exactly. Okay, so see, like the equal thing has to be supported. All right, anyways, task for future me. All right, now, anyways, if you want to keep an eye on how this evolves, PR222, that's an easy number to remember on the cel-rust repo. So go there, watch it, like it, fight it, whatever. Let's see what gives. All right, y'all. Thanks for dropping by again.